Now, in this video, I'm just going to talk about composition of functions. This just means we substitute one function in terms of another. Now, this notation, it just means that we have f of x, and on that we substituted g at x. So that's just what this notation means. This is what that notation implies. And if you're familiar with composition, then you already know how to do substitution in integrals. Now, how does this work? So suppose we have f of x, and we have another function g at x. Now, in order to get f compo g, that means we have to substitute g in f. Where there's x in f, you substitute g at x. Let me make an example. It's basically that simple, really. You can also have a composition of more functions, f compo g, compo h. So you have something like this. So basically, it's just the same procedure in this one. So let's just focus on what we have here, or what this notation means really. Now, if you focus here, you have the graph f of x, and then you substituted g at h at x. So you have f at g at h. So you have h at x substituted in g, and that is substituted in f. So that's what this notation means really. Okay, so suppose we have f of x is equals to 2x minus 6, and g at x is something like x squared. Now, what this means is that we can if we're looking for f compo g, that means that we have to, where there is x in f, we substitute g. So that means you're gonna have f of x, which is 2. Now we have x in f, that means we substitute x squared. So we're gonna have x squared, then you subtract 6. That makes f compo g to be 2x squared minus 6. That's f compo g there. But then we can also have that in reverse, g compo f at x. So this is where you have to be careful in multiple choice questions, because you can swap this and the option will be there. If you work it out incorrectly, the option will be there. Now, this means that where there is x in g, listen to me very carefully here. Where there is x in g, you substitute f. Now let's focus on g at x. G at x is x squared. Now we have x squared. I can just say I can put brackets here to make it simple. Then where we have x, we substitute 2x minus 6. So we have 2x minus 6 squared. That because that's x in g. So we substitute f there. Then we'll have 2x minus 6 squared, which if you expand, you'll have 4x squared. 2 times negative 6, that's minus 12. Multiply that by 2, you have minus 24. So you have minus 24x plus 36. So that's g compo f. And this is this is f compo g. Then that's how you can deal with composition of functions. Then you can also have something like a hyperbola. G at x equals 1 over x, and then you have a straight line function. Let's call it f of x equals 2x minus 6. And you can have another graph, h at x equals x squared. Now from this we can be able to find f compo g compo h. We can be able to find this function. What does this mean? First, try to write it in this notation to avoid mistakes. If you don't do this, you'll end up making mistakes, and the option will be there on multiple choice. Now, this means that we have f at g at h at x. We have f at g at h at x. So this means that we have f. Now we look at g at x. G at x, it's 1 over x. Now, where there is x in g, where there's x in G, we substitute h at x. We substitute h at x, so that means that we'll have 1 over what? Now where there is x, we put x squared, so we'll have 1 over x squared. So that then we can put the small brackets from them. Then you have f at 1 over x squared. Now, then this means that where there's x in f, you put 1 over x squared. So we'll have 2, where there's x, we plug in 1 over x squared, then minus 6 from there. Then that's basically how you can work it out. You can simplify if you want to, then you'll have 2 over x squared minus 6. So that's how you can deal with compositions. If you follow this strategy, you won't go wrong. But then if you do your things, then that's where you'll have a problem. You'll end up getting the things you know wrong. So just follow this strategy, and I just showed you an example of that, how this works. And then basically you can be able to deal with composition of functions. So this is it about composition of functions. But sometimes they can give you functions and they want them in reverse. They say find f and g such that the composition of that will result in whatever that's provided. So I'm just going to do one example of that, and then this will be it for this video. Now here we have a problem. Given that k at x is a composition of this function and it's provided to be x squared minus 4x. Now, if k at x is equals to x squared minus 4x, let me write that down. We have k at x is equals to x squared minus 4x. Since provided that k at x is x squared minus 4x, and then we have g at x equals x minus 2, and this function is a composition of that. We have g substituted in f, and the question says find f such that g is x minus 2. Now, this is a parabola, this function. So we can write that in standard form. So we have x squared minus 4x. You're going to complete the square here. So when you complete the square, you're going to add half of this number square. Since this is 1, so that's, you just take half of this number. Half of 4 is 2, and then 2 squared, that's 4. So you add 4, and then you also subtract 4. That's because you're basically adding 0 to the equation. Then now, this is a perfect square number. This is a perfect square term. Then you'll have x minus 2 squared. Then don't forget that you still have minus 4 in that. But now notice that x minus 2 is g. This means that g is substituted here. So, and now g is substituted in f. That makes f to be equals to x squared minus 4, such that if we substitute x minus 2 here, we'll get this function. So that's how you can find the graph if provided the composition and another one. Then yeah, you can be able to find the solution to f of x. By just mastering these algebraic skills, completing the squares and stuff, and also having the idea of what composition means, then you know that since we substituted x minus 2 in f, then you can be able to evaluate that one. Then you'll get f of x equals x squared minus 4. So as you can see, this is a composition, simple stuff. So they are not really that complicated. Thanks for watching. Don't forget to share and subscribe.